Hello, IMARC. Right up front, I want to tell you why I'm thrilled to be speaking with all of you. Your expertise has a unique play in what's next for our moon. And so today I'm excited to talk to you about what could be the next step on that road. I'm sorry I can't be there with you in person, but I am glad that you'll be hearing from my fellow U.S. government colleague, Dr. Dave Korsmeyer. His organization, NASA, has been a critical partner in the work that I'll share with you today. Now, I have the privilege of being a program manager with DARPA, the organization that brought you the internet, GPS, mRNA vaccines, and other inventions that you may recognize from your day-to-day life. DARPA is a really unique place, chartered to look 10 or more years into the future, think about what's possible from a technological point of view, and then drag that future into the present. So in that vein, about a year ago, I started a DARPA program called Luna 10, or 10-Year Lunar Architecture. I'll spend the next few minutes summarizing that program and use that as a jumping-off point to discuss how I believe the commercial mining industry can be part of a new international push to return to the moon. So let's start with the big picture first. Now today, each lunar lander or lunar activity must organically support all the resources it needs: power, communications, data, navigation, timing, thermal, in addition to whatever mission it's on the moon to perform. And so what that means is everything you send to the moon must be completely self-sufficient. And of course, that's not how industry works here on Earth. Cities grow and thrive due to a shared infrastructure and the sharing of resources across that infrastructure. That's what creates hubs that incentivize commerce. A sustainable commercial lunar economy should look more like city living. If I'm a commercial mining company on the moon, I shouldn't have to also be my own power company and data company and robotics company. I should be able to plug into an outlet and get power, have line of sight and get mesh networking, and so on. So, Luna 10 hypothesized that an integrated lunar infrastructure framework would upend the current technical paradigm, where today we have these unique, fully self-sufficient systems. Now, many services are needed to field a commercially owned and operated lunar infrastructure. I'm showing some of them here. An underlying common framework that emphasizes integrated models of economic activity may be the rising tide that lifts all lunar vessels. So in an analogous manner to how river ports turned into major cities due to growing infrastructure, what technology might catalyze lunar aggregation, the hosting of pay-as-you-go services, and the encouragement of further investment and diversification of the lunar economy? That was the point of Luna 10. So we explored hundreds of overlapping concepts in constantly changing pairings between these teams over tens of thousands of labor hours, including international participation. We asked these industry leaders from around the world to break down intellectual property barriers between them and answer new commercial-to-commercial service questions instead of government to commercial. So A sells to B sells to C sells to everyone, D brings it home. How would that play out technically, then in terms of interoperability, and then economically? And then we fused all of those answers into time-varying frameworks. If you're interested in more detail, I encourage you to Google DARPA Luna 10 and check out the links on the right-hand side of this page. There's lots more information that you can look through on the individual commercial technologies, as well as frameworks like this one that stitch them all together. This is a framework, not the framework, but it's intended to be a blueprint for a technically anchored, future, peaceful, international lunar economy. So Luna 10 focused on a complementary objective to that of NASA and the Australian Space Agency: concrete ideas rooted in today's commercial technology to create off-Earth economic vibrancy through these monetizable commercial services that could be provided to a wide variety of users on and around the moon. Okay, so that's Luna 10, but now let's talk about you, IMARC. Power, communications, navigation, robotics, construction, transportation. These are all examples of commercial services that may be monetizable and have infrastructure value. But here's the important question: what do those commercial services support? The utility case at the center of the lunar economy is what we're calling the anchor tenant, around which all the other services are based. So, what is the anchor tenant for the moon? And the answer is, you are. Today, the clear forerunner is mining on the moon, what's called ISRU, or in situ resource utilization. Unlocking a sustainable presence on the moon depends on the ability to utilize local resources. So some resources that are abundant on the moon include oxygen for propellant, water, and a variety of useful metals such as silicon for microelectronics and aluminum. Now, a complete ISRU-based lunar economy will need to develop industries that can utilize all available resources, but it's more than that. As the anchor tenant, you anchor all the other services that were part of Luna 10. Mining is power hungry, right? You need megawatt hours of power, and today we're at the watt-hour level, so lots of room for commercial growth there, terabytes of data, robotics as a service for remote maintenance of equipment in these harsh operating conditions. Think about transportation of heavy equipment to the lunar surface and then returning those mined resources back here to Earth. All these commercial industries have a successful business model if you are successful. So, for both Australia and the mining industry in general, you have unique expertise in harsh operating conditions and building hardware that can survive those. AROSE is already leading the way with their construction rover project, Rover. So let me pivot from there to what I think the opportunity space is for you in this Luna 10 paradigm that I've just gone through of a commercial lunar economy. So I see three things. First, let's talk about two-way learning between the mining industry here on Earth and ISRU on the moon. We don't really know what the composition is like beneath the surface. So how do we design to operate regardless of what's down there? In doing so, I want to stress the importance of designing for the Starship era. Speaking as a classically trained aerospace engineer, almost every design choice I've made on a rover or satellite has come down to mass and optimizing my design to minimize mass at all costs. When Starship can land 100 tons on the moon in one spot, we can build bigger and cheaper and more. So I ask you, what intelligent design decisions would you make to leverage known and well-understood mining equipment to go to the moon? A world in which we design lunar construction rovers the way we design cars is the world I want to encourage you to think about. Let's make the minimum number of changes to operate in the harsh lunar environment and then act together to accelerate the tech development of those components. Now that leads me to the second unique insight that I see for this community to contribute to a future lunar economy: testing. I'm a graduate of the U.S. Air Force Test Pilot School, and so I think about test and evaluation a lot. I would like to see more analog facilities where we can test quickly modified mining technologies for the Starship era. An example is leveraging existing facilities like the Australian Automation Robotics Precinct, where mining companies test already. That expertise and unique insight is key to thinking about the moon differently, more as an industrial activity than as an exquisite science project. So if Australia is looking for a unique way to contribute to the lunar economy, something like a grand challenge for ISRU testing would really galvanize the synergy, in my opinion, between the mining industry and lunar exploration. Imagine a Luna 10 in the Australian outback. Bring companies together, get them to collaborate, test interoperability between lunar power products, lunar comms products, and of course, lunar mining products. Show that you can be robust to unexpected factors, because there'll be plenty of those on the moon. The final thing I'll say, and I think about this a lot at DARPA, is to have a long bet. What is the high-risk, high-payoff thing that may be worth investigation? Now, my thought is it's the intersection between mining and biotechnology. As you know from terrestrial mining, not every resource may be commercially viable to extract. But if we go to the trouble of digging into icy craters on the moon, what can we do with all the extracted, moved regolith in a secondary process that can have slower but still valuable gains? Can we use biology, engineered anaerobic microbe farms and food stock, to process through that waste material and increase the profitability of the enterprise? I think that's an interesting bet with lots of technology white space yet to be explored. So when I think about the roles that Australia could play in the Luna 10 vision, there's a lot of synergy between this community and a future international lunar economy. Mining is at the heart of it. It's the anchor tenant. How do we mine in the Starship era? What can Australia offer the world in terms of a unique playground to rapidly test new commercial mining technology? And how can we make better use of mining byproducts on the moon to maximize economic margin, perhaps with biology, perhaps with other means? Finally, interoperability with international commercial companies is key. And so I encourage you to check out logic.jhuapl.edu to learn more about a DARPA-led effort to figure out these interfaces. We have over 40 countries that are members, with an all-volunteer force of over 900 motivated people eager to craft the future. And I hope that can include you very soon. Thank you so much for the opportunity to talk with you today, and thank you to the Australian Remote Operations for Space and Earth for the invitation. I regret not being able to be there with you in person today, but I hope I've stimulated some interesting discussions amongst you all. If you have questions, please reach out to my team and I at luna10@darpa.mil. We'd love to hear from you. Thank you, and good day.